All right, folks, just wanted to make a really quick video about the projectile practice problems for this week. I'm just going to give you some really quick hints for reviewing, I guess, some of the equations and concepts that you potentially will need to answer these. So, of course, go through and watch the notes, the video examples that I did earlier on about the 2D motion, projectiles, and circular motion notes. But here again, I'm going to do a real quick review for all of the questions that are in the practice problems. So the biggest thing I want you to know is that for questions numbers 1 through 2, they're talking about gravity in two different directions. I want you to remember that gravity is constant. Gravity is always at negative 9.8. So when you drop something and it's going down, it's going to be accelerating at that 9.8 meters per second squared. So if you started something at 0 meters per second, every second that it falls, it's going to be going 9.8 meters per second faster. Now, the complete opposite of that is if you throw something up and it's going this direction, every single second, it's going to be going 9.8 meters per second slower. So it doesn't matter if something's going up or going down, that negative 9.8 is constant. So in this situation, it's making things go faster. In this situation, it's making things go slower. But it constantly is 9.8. So that part's never going to change. So that's one of the main questions for numbers 1 and 2. For questions number 3 and 4, so this is for number 3 and 4, they talk about projectiles moving in 2 dimensions. They talk about this vertical versus this horizontal component. Just remember that there's distance in the vertical and the horizontal direction. So there's how high it goes and how far horizontally it goes. So those would be considered like your d of x and your d of y, depending on how high they go total. So if I talked about a projectile like this total distance across here is your d in the x direction, and the total height that it goes here is like your d of y. That's how high it goes and how far it goes total. But while it's in motion, the vectors that we're more concerned about are the velocities at any given point. And of course, if you call each one of these a velocity, the horizontal one's x and the vertical one is y. So at every given point, you'll see that these vectors maybe do or do not change. On a projectile that's traveling up, you'll see that the y decreases as it gets towards, say, the peak, and increases as it gets a little bit further down. The v of x we typically look at as being consistent, but either way, it's the vertical versus horizontal, or v of x versus v of y. For numbers 5, 6, and 7, so number 5, 6, and 7, there's 2 main things I'm going to tell you. First, worry about finding the time that this object is in the air, the time of free fall, okay? This is the equation for the time of free fall. I believe in the first question there in number 5, it's only asking you for the time, but for question 6 and question 7, you have to find the time before you can find the distance or the range. So as long as you have the height in meters and you have g as 9.8, make sure you multiply, divide, and then at the end square root, and that'll give you your time in seconds. The second thing, where they're asking you to find the distance or your d of x, how far something went, if you know the velocity, this has to be the velocity in the x direction, and you multiply it by time, that'll tell you how far it goes. So most of these are pretty straightforward. It tells you something's driving off a cliff, and the horizontal velocity is, whatever. As long as you know the time from up here, you can plug it in, and life is good. For the next set of questions, these talk about circular motion or centripetal acceleration. So this is for number 8, 9, and 10. So the first equation you're going to need to know is the centripetal acceleration equation. The centripetal acceleration is equal to v squared over r. For most of these, I give these directly to you. The force centripetal is mass times acceleration, just like anything else, except for the acceleration is this whole equation above, so you can substitute in that if you want. And remember that the inward seeking force on any turn, corner, something spinning around, this is the centripetal force. So I always try to tell people, think of like pedaling a bike or pedaling something in a circle, and you're turning and you're putting your energy into the center to get something to move. The centrifugal force is kind of the opposite, invisible, non-existent, the reactive force of the centripetal force. And then there's some questions that talk about how changing certain variables will affect centripetal force. So just really think of this whole thing to be your summarized equation for force centripetal. It's the mass times the centripetal acceleration. Remember the numbers on the top. If you increase m or increase v, it's obviously going to make the force go up because these numbers are on the top. They get bigger, they're larger. If the number on the bottom, the radius, if this gets bigger, you're making this smaller because you're dividing by r. So if r originally is 10 and then later on r is 100, it's going to be 1/10 of whatever it was before, because instead of dividing this whole value by 10, you're now dividing it by 100. So when this goes up, this goes up. Goes up, that goes up. When this goes up, this would go down, or vice versa. When this goes down, then this would go up. So the bottom one's kind of opposites. The top one is the same. So they call it a direct relationship and indirect relationship. And that's mostly it for this week's, folks. Let me know if you got any more questions.